Soil nailing, stabilizing slopes effectively. Welcome to Blueprint to Reality, the channel that turns complex civil engineering concepts into simple, powerful knowledge. Today, we're diving into one of the most efficient and widely used techniques for slope stabilization, soil nailing. Whether you're dealing with highway cuts, retaining walls, or deep excavations, soil nailing has become a go-to solution. In this video, we'll cover what soil nailing is, how it works, when to use it, and its design, construction, advantages, limitations, and real-world applications. What is soil nailing? Soil nailing is a ground reinforcement technique used to stabilize slopes, excavations, or retaining walls by inserting slender reinforcing elements, called nails, into the soil. These nails act like passive anchors, working in tension to hold the soil mass together and resist movement. It's like giving the earth its own internal skeleton, helping it resist sliding or collapsing. How does soil nailing work? The process involves drilling holes at regular intervals into the slope or excavation face, inserting steel bars, the nails, and grouting them into place. The face is then often covered with shotcrete and mesh to prevent erosion or surface movement. When soil tends to move, these nails mobilize tensile forces that stabilize the entire structure. Unlike active anchors, soil nails don't need pre-stressing. They gain strength as the soil tries to move. When is soil nailing used? Soil nailing is ideal for 1. Temporary or permanent excavation support, especially in urban environments. 2. Stabilizing highway and railway cut slopes. 3. Reinforcing retaining walls that are starting to fail. 4. Preventing landslides in natural or man-made slopes. 5. Tunnel portal stabilization. It's particularly useful when space is limited and when open-cut or traditional retaining methods aren't feasible. Step-by-step construction process. Let's break down the construction sequence. Step 1. Excavation. The process is typically top-down. A portion of the slope or excavation is cut. Step 2. Drilling. Drill holes into the exposed face at a slight downward angle, usually 10 to 20 degrees from horizontal. Step 3. Inserting nails. Place steel bars, usually fully threaded rebars, into the drilled holes. Step 4. Grouting. Fill the hole with cement grout to bond the nail with the surrounding soil. Step 5. Facing. Apply shotcrete, wire mesh, and sometimes drainage strips over the face. Step 6. Repeat. Excavate the next layer and repeat the process until the full wall is constructed. Design considerations. Designing a soil nail wall involves 1. Geotechnical investigation. Understand soil type, strength, water table, and slope geometry. 2. Nail layout. Determine spacing, length, inclination, and diameter. 3. Factor of safety, FOSS. Ensure FOSS greater than 1.5 for permanent and greater than 1.3 for temporary structures. 4. Drainage. Include proper drainage to reduce water pressure behind the wall. 5. Facing system. Choose between temporary shotcrete or permanent structural facing. Advanced design may use software like Plaxis, Slide 2, or GeoStudio for stability and FEM analysis. Advantages of soil nailing. Cost-effective, less expensive than traditional retaining walls. Quick installation. Faster than sheet piles or soldier piles. Minimal footprint. Requires less space. Ideal for tight urban sites. Flexible design. Adapts to irregular geometries. Safe for deep excavations, especially useful in staged construction. Limitations and challenges. Not suitable for loose or very soft soils. Soil must have at least moderate shear strength. Groundwater issues. High water tables can complicate installation. Limited to temporary support in some cases. Permanent walls need corrosion protection. Construction vibration. Nearby structures must be assessed for vibration sensitivity. Requires skilled labor. Proper installation and grouting are critical. Comparison with other techniques. How does soil nailing stack up against other methods? Versus retaining walls. Soil nailing is less rigid, more flexible, and faster to build. Versus ground anchors. Soil nails are passive. Anchors are active and pre-stressed. Versus sheet piles. Soil nailing is quieter, less invasive, but may not be as deep. Use soil nailing when speed, cost, and flexibility matter, especially in urban environments or where excavation depth is under 15 to 20 meters. Real-world examples. Soil nailing has been successfully used in Seattle's I-5 highway widening project for temporary slope support during excavation. London underground stations, stabilizing tunnel portals and shafts. Metro systems in Asia, supporting deep excavations near existing infrastructure. It's also used in residential projects built on steep terrain, helping retain natural slopes while building on or below them. Conclusion. Soil nailing is a versatile and effective method for stabilizing slopes and excavations. Its ease of installation, adaptability to complex sites, and cost efficiency make it a go-to solution in modern geotechnical engineering. But it's not a one-size-fits-all technique. Proper design, site analysis, and construction are crucial for success. If you found this breakdown helpful, give it a like and subscribe to Blueprint to Reality for more practical civil engineering content. Until next time, build smart, stay grounded.